Hey guys, hey everybody. Sorry I can't be there in person today, but hopefully the video of these notes will help. If you can't get it just from copying them down, feel free to watch as much as you need to, skip around to the stuff you don't understand. At least this way you've got me explaining it if you need it. Okay, so we all know Pythagorean theorem. We talked about that a couple days ago. The Pythagorean theorem basically says if we have a right triangle, then we can add the squares of the two legs, and that's equal to the square of the hypotenuse, or a squared plus b squared equals c squared. Today we're going to do the converse of the Pythagorean theorem, which says basically that if I know a squared plus b squared equals c squared, then I know that it's a right triangle, right? So basically we can say that if a squared plus b squared equals c squared, then it's a right triangle. So if you've got three side lengths and you want to know, does this make a right triangle, I can plug it in, and if it works, then it does, right? But the nice thing about this is that it also helps us find other types of triangles. So we can take those three numbers and use this Pythagorean theorem to see what kind of triangle it is, okay? So for our first one, like we just said, we can see if it's a right triangle, if it's equal to it, right? So for example, if I've got a triangle and I know the side lengths are 5, 12, and 13, right? So I like to start with my hypotenuse on the left side, and I'm going to show you why here in a minute, but I would recommend it. Just makes it a little bit easier. So I'm going to plug it back into the Pythagorean theorem, basically. So I'm going to say 13 squared. That's my, or would be my hypotenuse. In this case, I know it's the hypotenuse because it's the longest of the three sides. I don't technically know that that's a right triangle yet. So I do my 13 squared, and I want to know, is it equal to, so I'm going to put a question mark up there, 5 squared plus 12 squared. And then I'm just going to calculate each side and see if that works. So 13 squared is 169. 5 squared is 25 plus 12 squared is 144. And if I add those two together, I do in fact get 169. So since those two sides are equal to each other, then that means that this is a right triangle. And we can add in our little right angle there. Okay, so if you plug them all in and they equal, then we've got it. That means it's a right triangle. So we're testing it here in the beginning and then seeing if it's equal. Okay, so the other two, we can also use this theorem to find out if it's an acute or an obtuse triangle. So we can see what kind of triangle it is. Okay, so let's take another triangle here. And let's say we've got side lengths of 6, 7, and 8. Just kind of pick three numbers here, right? So again, I'm going to take the biggest number. That's the possibility for my hypotenuse. So in this case, it would be 8. So I'll do 8 squared. And I want to know, what's the relationship here when I look at 6 squared plus 7 squared, right? So 8 squared is 64. 6 squared is 36, plus 7 squared is 49. So then 64, and if I add 36 and 49, I get 85. So that means 64 is smaller or less than 85. Since the hypotenuse is smaller, right, or that square of the hypotenuse is smaller, then that means that that angle across from that longest side is going to be a smaller angle. And it means all our angles are going to be smaller then, because that's the biggest side. So that means that this is an acute triangle. So all of our angles are smaller than 90 degrees. Okay. And then one more, we'll do three other lengths here. Let's say 4, 5, and 8. And we'll do the same thing here. So again, 8 squared, that we know is 64. That's our biggest side again, right? And then we'll do 4 squared plus 5 squared. That'd be 16 plus 25. And in this case, we're going to get 64 compared to 16 plus 25 is 41. So this time 64 is bigger than 41. So that means that angle across from the 8 is going to be larger, right? So this time, because the hypotenuse squared is bigger than the 2 sides squared, that means that this, is an obtuse triangle, meaning that angle that's across from the longest side is an obtuse angle. So over here would be an obtuse angle. Okay, so we can use that to decide what kind of triangle we've got. Okay, just deciding or doing a couple more of these, right? Now, the other step we need to do here is something we did in the last chapter. So before I can use that Pythagorean theorem to decide if it's a right triangle, acute triangle, or obtuse triangle, I first have to decide, can it even be a triangle, right? So remember, when we decide if something is going to be a triangle, we have to add together the two smaller sides, and those two have to be bigger than our third side or our longest side. Okay, so before you decide, is it right, acute, or obtuse, I have to decide, can it even be a triangle? Okay, so I'm going to start with this one here. So my two smaller sides are the 1 and the 4. So if I do 1 plus 4, that's 5. And then I want to compare that 5 to my bigger side here. Well, 5, this sum here needs to be bigger than 5, but it's not, right? So that means that this is not a triangle. I don't even have to test, is it right, obtuse, or acute, because it's not a triangle at all. Okay, let's try our next one here. So 8, 10, and 12. So I pick my two smaller sides, 8 and 10. 8 plus 10 is 18, and 18 is definitely bigger than 12. So that means it checks out. We can use it as a triangle. So now I'm going to check to see, is it right, acute, or obtuse? So I take that biggest side again, the 12. That's going to be my potential hypotenuse. So I'm going to do 12 squared. And then I want to compare that to 8 squared plus 10 squared. So 12 squared is 144. And then we've got 64 plus 100. So that 144 compared to 64 plus 100 is 164. So our 144 is smaller, right? That potential hypotenuse is smaller, or the square of it is smaller than the 2 legs squared. So that means that this would be an acute triangle. Okay. All right, and we've got one more over here. Again, we have to check to see if it's a triangle first, right? So before I can check to see what kind it is, it has to be a triangle first. Okay, so my two smaller sides compared to the bigger one. Now, this is all radicals, right? Hopefully, you can see that the two radical 7s, the square root of 7 is smaller than the square root of 14. But remember, you can always just type these into your calculator and get approximations if that's easier for you, right? If you need to double check it. Okay, so if I do radical 7 plus radical 7, that would be 2 radical 7, right? I can add those together because they have the same number inside the radical. And then I want to compare that to radical 14. Now here's where it might be a little bit harder to think about. So again, change them to decimals if you aren't sure with the radicals, right? You can kind of estimate it a bit, but I still think the easiest way is just type it in your calculator. If I do 2 times radical 7 in my calculator, I get approximately 5.3. And if I do radical 14 in my calculator, I get 3.7. So that means that this is definitely bigger than radical 14. So that checks out, and it is definitely a triangle. So we're good to go. Okay, so now we do the next step. Again, we want to take the biggest side to be our potential hypotenuse. So my square root of 14 is the biggest one, and I'm going to square that. And then I want to compare that to radical 7 squared plus radical 7 squared. Right? We're going to square that whole thing. Now, when I square a radical, a square root times a square root just means it's just the number, right? So this would be 14, and then this would be 7 plus 7. So that means 14 equals 14. So that means that this would be a right triangle. Okay? So 2 steps there. When you're trying to classify a triangle, if you're given the 3 side lengths, first you have to decide, can it even be a triangle? And second, you can use the Pythagorean theorem to decide, is it acute, obtuse, or right? In my past teaching this class, I've had lots of people forget to do that first step. So just don't forget to decide, is it a triangle first? Okay. On the back here, we'll do a couple other little examples just to make sure we've got it, right? Okay, so on this one, we've got a triangle, and we have two sides, 8 and 6, and we don't know the length of the third side. It's just x, right? This one here, by the way, is not a measurement. It's just naming it angle 1, okay? Okay, so we want to know, like, what values of x are going to help us get different types of triangles, right? Okay, now the first one we've talked about before. I just want to make values of x that will make the triangle exist. So what's the smallest possible value x can be? What's the largest possible value that x can be? We did this on the last test. This is just where I'm going to take the two numbers and I'm going to add them together, and then I'm going to take the two numbers and I'm going to subtract them, right? So if I do 8 plus 6, I get 14. So that is the biggest that it could be, or it has to be smaller than that. And if I do 8 minus 6, I get 2. So that third side has to be bigger than that. So that means our x has to be between, and if you want to do between, you can always do two less than signs, 2 and 14. It can't equal those, right? If it equals those, it won't work, but it can be smaller than 14 and bigger than 2. So those would be the values of x that would actually make this be a triangle. Okay. Okay, so now I've got the possible values of my x to make it a triangle. So now the next part, I want to say, well, what if angle 1 is a right angle? So what if this angle over here was my right angle? That would mean that x has to be my hypotenuse, right? So if I want angle 1 to be a right angle, that means I want this to be a right triangle, and x is my hypotenuse. So that means that my x squared has to equal the sum of the squares of the legs. So 8 squared plus 6 squared, right? So our Pythagorean theorem has to work. So if we go through the work there, we get 64 plus 36. So x squared has to equal 100. So that means that x has to equal 10 in order to make angle 1 a right angle, right? Okay, and notice that 10 is in between the 2 and the 14. So that means it works, right? Okay, great. Well, now what if we want our angle 1 to be an obtuse angle, right? Well, if I want angle 1 to be obtuse, I want it to be the bigger angle. That means I want my x squared to be bigger than the sum of the squares of the other two sides. So I want my x squared to be greater than my 8 squared plus 6 squared, right? Well, and if we think about what we've got in our previous steps up here, right? We know that if x is 10, that means it's a right triangle. So that means our x has to be bigger than 10, right? So we know x has to be greater than 10. But then also from up here, we know that x can't be bigger than 14, right? To make it a triangle. So x has to be less than 14. So really, we don't even have to do the algebra over here. We can just use what we know from the previous two parts, that x has to be bigger than 10 and smaller than 14. So I can write that all as one inequality here. It has to be in between 10 and 14 in order to make that an obtuse triangle, right? And then finally, if I want this to be an acute angle, again, that would mean that our x squared is less than 8 squared plus 6 squared, right? Or, again, if we go back up here, we'd know it'd have to be less than the 10, right? Because this time we want it to be smaller. And then up here, we had a restriction that x has to be bigger than 2 to make it a triangle. So x has to be bigger than 2. So in this case, our angle, or our side, would have to be between 2 and 10 to make it an acute triangle, right? So kind of putting this all together, right, we started with finding just these possible values of x. And then if we find the value that makes it a right triangle, then all the values bigger than that, but less than our max restriction, would make it an obtuse angle. And all the values smaller than my 10, but bigger than our minimum for the triangle, would make it acute. Okay, so hopefully you can kind of see how those pieces all work together. Okay, last part down here. we want to know, is ABC a right triangle, right? So basically, if ABC is a right triangle, I've got one side of 20 and I've got another side of 15, but I don't know my third side over here, right? So looking at this picture, hopefully you notice that we've got another right angle here, right? That's not part of my angle for my triangle ABC, but it is an angle in my two smaller triangles. And I know two sides of, here, let's get a better color here. So if I look at this triangle here, right, I know the 20 and the 12, and that's a right triangle as well, right? So we can look at that triangle and say, well, if I make this my x, the 20 would have to be my hypotenuse because it's across from my right angle. So I know my x squared plus 12 squared would have to equal 20 squared. I already know that's a right triangle. Oops, not 20 degrees, sorry, 20 squared. So I can just use Pythagorean theorem to solve for that side. So we get x squared plus 144 equals 400. So x squared will equal 256, which means that x equals 16. Okay, so now we've got this side here that we know is 16. All right, then if I look at, let's get a different color here, this triangle on this side, right? I've got two side lengths there. I've got the 15 and the 12. So I can do, if I call this one y, say, 12 squared plus y squared equals 15 squared, right? Again, that hypotenuse is across from my right angle. So 144 plus y squared equals 225. So then y squared is 81, which means y equals 9. So now we know that this side here is 9, right? Okay, so now I can look back at that triangle ABC, right? I'm going to draw it separately over here so we can see it better. And I've got this side is 20, this side is 15, and now if I add the 16 and 9 together, that means this side is 25, right? So that means if I want to see if that's a right triangle, well, my potential hypotenuse is the 25. So I'm going to do 25 squared, and I'm going to compare that to 15 squared plus 20 squared. And we get 625 here. This would be 225 plus 400. And if I add those together, we get that they are equal. So yes, it is a right triangle based on what we did there, right? By the way, if just in case you thought of it, when you were working on this triangle over here, this is also, some people might think like, well, I could have used geometric mean here, but you can't use geometric mean because we don't know for sure that that big triangle is a right triangle. So you've got to use your Pythagorean theorem in two ways there to get those missing sides. Okay, but hopefully that makes sense. If you have any questions, I'll be around this afternoon. Feel free to give me a Google chat or something if you need some help. And I will see you guys, not tomorrow because we don't have class tomorrow, but I will see you on Thursday. Have a good one.